In this video, I'll talk about the relationship between a power supplied by a battery, the voltage, the current, and the resistance. Or if you have to calculate how much power is dissipated by a light bulb or by any resistor. So I'm going to talk about that relationship here. So let us consider that this is the filament bulb, any light bulb, and R is the resistance. I is the current and the delta V is the potential difference. So this battery is supplying the current or supplying the electrical energy, and all this electrical energy is now being dissipated by this filament. So this energy is coming out of this filament in the form of heat energy, in the form of light energy. Okay. So there is no any charge storage. What does that mean? That means all the energy, electrical energy supplied by this battery is now dissipated by this light bulb or this filament bulb. The power supplied by this battery is given by this equation here, I times delta V, and the delta V is the potential difference. As there is no energy storage at any point, that means all the energy that is dissipated by this filament is given by this equation 2, I times delta V, where the delta V is the potential difference across the battery or across the filament bulb. So from conservation of energy, whatever energy is supplied has been dissipated in the form of the light energy or the heat energy. So all the energy that is supplied by this battery must be equal to the energy dissipated by this filament bulb. So the P supplied and this energy has to be exactly equal. So that's what it says here. So if you look at in terms of the energy 2, that means all the energy that is produced by this battery in the form of chemical energy, the battery does have a chemical energy, or that means the rate at which it produces energy inside the battery is exactly equal to the rate at which this filament bulb is dissipating the energy, or means the chemical energy that is producing inside this battery, the rate is exactly equal to the rate at which this filament bulb is dissipating the energy. So that must be exactly equal. So there are other formulas for calculating the power. So I'm going to write down here. So P so far is equal to I times V. And we know that V is equal to I times R. So once I plug in here, what I get is I times V is equal to I times R. So this is equal to I squared times R. Okay, so this is another formula. So if you know the resistance, then you're going to use this formula. If you know the resistance, and if you know the current, then how much power is dissipated can be calculated by this formula. Or if you know this potential and this R, you can also solve for this one. So from this equation, if I have to solve for I, then I is given by V and divided by R. Now let's plug this current into this equation. What I will get now is power is V divided by R times V, which is equal to V squared over R. So any formula can be used to calculate the power dissipated. Okay, and the unit of this power is watt, which we will also call by joule per second. And if you have to calculate how much energy has been used, then you know that the power is basically the energy divided by the time. How much energy is dissipated in 1 second is the power. The energy per unit time is the power. So if we have to solve for energy, then this is power equals to time. That's the energy. The unit of energy is joule, the unit of power is watt, and the unit of time is second. So that's, it has to be the second here. That's the unit of the time. Okay, so in the next video I will give you an examples of calculating the power by a light bulb, how much energy has been used, and I will do that in the next video. So this is it from the video. If you have any questions, let me know, and do not forget to like, share, and subscribe the channel. Thank you.